Electric generator. We all know that mechanical energy is the sum of kinetic and potential energy. But do you know how this energy is converted into electric current in generators? Let us study this module to answer this question. In this module, we will learn about electric generators. Principle. Electric generators are based on the principle of electromagnetic induction, which means whenever the amount of magnetic field through a coil changes, an induced potential difference is created, due to which current is induced in the coil. Construction. It consists of a rectangular coil with a number of copper wires wound over an iron core. The coil is called the armature. It is used to increase the magnetic flux. A strong permanent magnet is placed and the armature is rotated between the magnets where the magnetic lines are perpendicular to the axis of the armature. There are two slip rings, R1 and R2, connected to the arms of the armature. The inner side of these rings are made insulated. Two metallic brushes, B1 and B2, are connected to the slip rings to pass current from the armature. The outer ends of the two brushes are connected to the galvanometer to show the flow of current in the external circuit. The current is passed through a load resistance which is connected across the slip rings. Working. Now, let's see how electricity is produced when we rotate the single loop of a conductor in a magnetic field. During its first rotation, conductor Rs is moving upwards and PQ is moving downwards. Therefore, according to Fleming's right-hand rule, the induced current will be in this direction as shown here. And the current in the external circuit will flow from B2 to B1. During the second rotation, conductor PQ is moving upwards and Rs is moving downwards. Therefore, according to Fleming's right-hand rule, the induced current will be in this direction as shown here. And the current in the external circuit will flow from B1 to B2. Hence, the induced current in the loop changes its direction continuously. The direction of the induced current in the conductor can be determined by Fleming's right-hand rule. According to Fleming's right-hand rule, if the thumb, forefinger, and middle finger of the right hand are stretched to be perpendicular to each other, and if the forefinger represents the direction of magnetic field, the middle finger represents the direction of induced current, then the thumb will represent the movement of conductor. To get the direct current, use split rings in place of slip rings, so that one brush is always in contact with the arm that goes downwards. The current given out to the outer circuit is in the same direction. This type of generator is called a DC generator. At different time intervals, the position of the armature keeps changing. When the magnetic field lines are perpendicular to the coil, The coil is rotated in the magnetic fields and an induced current is produced. This happens because the number of intercepting magnetic field lines passing through it is maximum. Now, let us revise what we have studied so far. Electric generator is based on the principle of electromagnetic induction, which means whenever the amount of magnetic field through a coil changes, an induced potential difference is created, due to which current is induced in the coil. Fleming's right-hand rule is used to find the direction of the induced current in an electric generator. Assessment and answers.